Hi guys, welcome to our channel Swipe to Learn. Today we'll be back with another new video on Python series. Those are function wrappers. If you go with the function wrappers, we see the concepts like iterator, generators, decorators. These concepts are discussed very less in the Python series, but they play a very important role as this is most asked in interview questions. You'll be asking about what is a generator and what is a decorator. At the time, you'd be able to answer what those are, right? So let's see about in detail. So what is an iterator? An iterator is an object that can be iterated upon. Like it's just generates a sequence. Like a list, tuple, dictionary, you'll be setting all are called as iterable. Iterable means one they have next value. As you see in OOPS concepts, you see about the iter and next. Iter returns the iterator itself, whereas next returns the next value in a sequence. You can just simply learn what is an iterator is. It's just a sequence. You'll be having a sequence of values, say 1, 2, 3, 4. Def iter returns it iters all the values, numerical values. So we can say it as 1, 2, and 3. Right. Moving on to next. If you go with the def init here, self.i equals to 4. Here, this program, as you see, it generates an iteration from the value n. If you see here, I'm giving n as 10, right? So if I give n as 10, list of n, so whenever I call this, self.i is defined as 4 initialization. As you know, def init is initialization, and then self.n equals to 10. So from the series from 4 to 10, it gonna generate the iterator sequence. So def iter, it follows return self and next. If self.i less than n, what is self.i here? Self.i is 4. 4 less than 10 is true. So I equals to self.i and self.i I is incremented to 4, 5 and written I is printed here. Same way in the next iteration 5 less than 10 is true. Again it gonna print I and it reiterates 5 becomes 6. Like that it generates a sequence from 4 to 9. Right? Got the point? Let's move on to the next. Why iterators? Iterators, they helps in lazy evaluation, like lazy iterables. We no need to work with each and every iterable, and it won't calculates the previous elements. It's saves us lot of memory and CPU time. And we have many built-in classes for iterators like enumerate, map, filter, zip functions. You have already discussed about all these functions in the Power Trio, right? Let's move. So generator. Same generator is the same like a regular function, but we use yield keyword in the place of return. Return and yield gives the same output. See, yield. So here a test sequence num equals to 0 while num less than 10 yield num. Read the same function in place of yield, use return num. Return num, what return nums? It prints the number, right? 0. Instead of it's a kind of print num or return num, but in the functions it is yield num. So yield num returns the value of num 0, num plus 1. Num is increased, num 2. 2 oh sorry 0 plus 1 1 1 less than 10 is true, so again yield num 1 is printed. Again, num is incremented. Next, num will become 2. 2 less than 10. It's true. So, yield num 2. In the same way, until num is less than 10, that is up to 9, the sequence get printed over the output. This is how a generator works. You can just simply, roughly, you can understand that generator is it generates a sequence, but it is same as a regular function, but uses the yield keyword instead of return. So we can also put generator in loops. So here we have a reverse string. So length, it just generates the length. So it is going in the backward length of -1, -1, -1, how you go with the string reverse. Now, instead of printing the characters, I am just giving return test of string. You can use yield test string. So you're keeping it inside the for loop. So you can also keep an yield statement in the for loop itself. So here, this is the Trojan, and the Trojan for each character, it starts the iteration loop from n until t. It's gonna print all the output from the reverse. This is how generator in loops works. Now, let's see with the generator expressions. So expressions are like, about list comprehension, right? Power cube for X in test list. So it generates all the cubes for the test list. Like 1 cube, 3 cube, 6 cube, 10 cube will be your list comprehension. In the same way, you can also generate test generators like X cube for X in test list followed by params. The same as list comprehension, you can also use with in the followed by tuple. This is called as a generator expression like list comprehension. You should check, like, this will be the same output, but list comprehension gives in the square braces, whereas the generator expression will be in the round brackets. If you go on checking with the type of test generator, then it generates the class of generator, and printing is no, you have to specify, I mean, you have to convert the object into tuple and you have to print it. So this is how generator expression works. It's like same of the list comprehension and this generator expressions. Decorator is a very important concept and mostly used in the placements. I mean, during interviews, a decorator is in Python is called a Python object that is used to modify a function. Like it adds some functionality and returns it. So decorators are simply you can define a function, you want to decorate it, like you'll be adding some functionality or some modified code and you'll be written. So these are of two types, function decorators and class decorator. If you use the decorator for the function, this is called as function decorator. If you use it for the class, then it is called as a class decorator. So here is the code looks like: test decorator, def function wrapper. So I'm using at the rate of test decorator. Here it starts the decoration. Here is the function square root of n. It returns the square of a number. So I'm just printing before calling the function name, result equals to function of x. I'm calling the function, and then after calling the function name, you will be getting in the function wrapper, and you will be taking an input n, and it will be generating the square root of 54. A square of 54, that is 2916 will be the answer. But you know about the function name here because of this test decorator, right? Closures. Closure are nothing but the functions that are written by another function. Like a function within the function is called as a closure. Suppose the def add number is a function and adder is the closure here because it's within. So adder is a closure, return num plus number. It just takes the number, and for the, I mean, the super variable that is num, the inner function variable is added. So it gives the resultant of these two variables. So I am creating a variable a of 10. A of 10 equals to add number of 10. So I want so add number of 10. So I am having a function with it. So you can create a of 10 object, and you can just, without specifying the adder function, its closure in it, you can just pass the parameter like a of 1021. A of 1021 implies you are adding, like a of 10 is add number of num, you are just calling adder of 21. So what adder of 21 has, it's already has the add number of 10, like add number of num. So it goes to superior and takes num, and it adds num plus the number. Then the resultant would be 10 plus 21, that would be 31. So this will be the output of the closure. Congratulations on mastering generators, iterators, and decorators. Keep practicing. We'll be back with another new episode in this Python series. Thank you guys for watching. Please do like, share, and subscribe. Swipe to learn.